Let us discuss how an external force can perform a work on a rigid body. On this rigid body, let us assume that at this point, a force F is acting from outside, the external force. This force can produce a torque about the center of mass of the rigid body. When the torque experienced by the rigid body about the center of mass is non-zero, then it can rotate. The torque experienced by the rigid body with respect to its center of mass or about its center of mass is tau is equal to R cross F. R is the position vector of the point. It is this force is acting with respect to the center of mass, and tau is the torque experienced by the rigid body about the center of mass. This will produce a rotation by producing an angular acceleration. We have talked about it in dynamics of rotation. So this force can have a rotational effect. A rotational effect of the force. The torque produced by this force about the center of mass is the cause of rotation, not about any other point of the rigid body. Tau c causes rotation. So this can be analyzed in two ways. This rotational effect given by tau c, and this produces an angular acceleration. Eventually, its angular velocity will build up from 0 to omega, and you can call that the body is rotating. Therefore, tau c is the cause of rotation. Torque about the center of mass of the rigid body is the cause of rotation. Therefore, this force has this rotational effect. Apart from this force can produce a translational effect. The force can produce the translational effect by accelerating the center of mass. We can imagine that same force is acting at the center of mass. So F is equal to m into AC. When the center of mass accelerates, if the center of mass is stationary initially, after some time it will attain a velocity Vc. When Vc is not equal to 0, then the body is said to be translating. So this is called translational effect of the force. The translational effect of the force. So any force acting on the rigid body has two effects. One rotational effect, one translational effect. The rotational effect can give us omega. The translational effect can give us Vc. So the kinetic energy of the rigid body will change. Both rotational kinetic energy and translational kinetic energy may change. Therefore, the force can change both the energy, rotational and translational kinetic energy of the rigid body. How much work this force is doing, that we need to calculate, and that must be equated with the total kinetic energy change of the rigid body. That is what we call work energy theorem. For that, we need to calculate the work done by this force at first. Let us assume that the point at which this force is acting undergoes a displacement with respect to ground, that is dsp, a very small displacement of this point of application of this force during a very short span of time. The angle between these two is in general can be assumed as theta. Then the work done by the force F, needless to mention with respect to ground, is Tw is equal to F dot dsp. The work done, the elementary work done, the total work done by this force can be written as integral F dot dsp. dsp is the displacement of this point P with respect to ground, that is equal to dspc plus dsc. Galilean transformation of displacement. dspc is the displacement of this point with respect to the center of mass, and dsc is the center of mass displacement. So you can write F dot, instead of dsp you can write dspc plus dsc. Let us integrate it. F dot dspc plus F dot dsc. Now we have to analyze each term carefully. dspc is displacement of this point with respect to center of mass, and that must be perpendicular to the position of the point P with respect to the center of mass. This is dspc, and the center of mass displacement should be added. The center of mass is displaced in this way. When you add these two vectors, you are getting this vector. dsp is the displacement of this point with respect to ground, dsp is the displacement of this point with respect to the center of mass, and dsc is the displacement of the center of mass with respect to ground. Let us take the first term. Displacement of the point with respect to C can be written as d theta cross r. R is the position vector of P with respect to C. Let it be R. R is the position vector of P with respect to C. Or you can call it simply R. You can write ds pc as d theta cross r. integral of this plus F dot dsc. We have two terms. This is the first term, this is the second term. Let us take the first term is F dot d theta cross r integral. This can be written as A dot B, can be written as B dot A. So you can just write d theta cross r dot f. And we can interchange the cross and dot. The next step, we can write d theta dot r cross f. R cross f is RPC cross f or R cross f is the torque of this force with respect to the center of mass. That is tau c. So you can write this as tau c dot, because this is none other than the torque of the force F with respect to the center of mass frame. A dot B can be written as B dot A. Therefore, the first term will be equal to tau c dot d theta, and the second term, is F dot dsc. This is the work done by the force F in shifting the center of mass. And this is the work done by the external force F in twisting or rotating the center of mass. Shifting, or you can call it translating. Therefore, the work done by this force, the total work done by this force is none other than work done by this force in translating the center of mass plus work done by the force in rotating the rigid body. So this force has two effects. This force can translate, it can also rotate the rigid body. So how much work is being done by this force in translation can be given by the second term. How much work is done by this force in rotation to rotate the rigid object is given by the first term. So the total work, if we sum up these two works, we are getting the total work done by this force in translating and rotating or in moving the rigid object. So in next class, we will talk about the change in kinetic energy of the rigid object when it is undergoing both translation and rotation. Then we can equate the translational term of the work with the translational term of the kinetic energy, rotational term of the work or the rotational term of the change in kinetic energy. That is what we will call the work energy theorem for the rigid object.